Go Language Programming, Chapter 5, Unit 7. In this unit, we will cover write slice to a file, read file into a slice, use OS package for standard I/O, use I/O package to read a file, use I/O package to read a string to a file, the ioUtil package read file line by line using bufio package. So let's start with the write slice to a file. So write successive string slices directly to a file. So this program or this code example 5-11 will tell us how you can write slices directly to a file. Okay, so to do that, we have a package main, so we can compile this piece of code and generate an executable, and we import these two packages, FMT and OS, and then we have a body for the main routine, entry point routine. Within the body, which starts at line 7, we create a variable called proverbs. Okay, that is a slice of string. Okay, so proverbs is a slice of string that we are creating right here, and giving all the data. So basically, this will be initialized with that. At line number 14, what we are doing is we are using our OS package to create a file. The file name so we have a file which will be created in the current directory, dot and forward slash and then the name of the file that will be created in the current directory. So you can create a file in a different directory if you want. All you have to do is to change this little bit and give the path, complete path for the where the file should be located. But in this case right now, the file will be in the current directory, and the file name is a proverbs.txt. Okay, and then we are using this short declaration. So we the return values from a create function, which is coming from the OS package, and it is returning two values. One is the error type, and the other one is a file handler will be saved. And we check, very first thing we check if the error is not nil. So if anything happened, then if while creating the file, if something happened, then it is going to be not not nil, meaning the error will not have a nil in there. So in that case, it will come right here. Okay, and it is using a print line function, and it will just tell us what error it is. And then from the OS package, and remember this is now exit function, which is the part of the OS package. We're calling it and basically passing 1. So that means by passing 1, that means some abnormal condition occurred. Similar to C or C++, that you use an exit function from within your code. You either pass some number, or you pass 0. 0 means normal basically we exited ourselves. That's what we wanted to do. But when you pass some other number, those numbers are representing the some underlying OS calls that you can use for determining why this program failed. Okay, so if you use a zero in here, then that means uh, the um, uh, the termination of the program occurred normally. If you don't use a zero, then that means the termination of the program happened abnormally. Okay, that's what this number represents. And then right after opening up the file, this os.create will create and open the file. So you want to defer the file, not to close it right away. So we use a defer call. So you always, every time that you're working with the files, you always will be using the defer call. Okay, and in this case, we are saying that okay, don't close the file, you just wait until the end of the function occurs right here. So that's what it is going to happen. So the file is not going to be closed until the end of this function. Now, with the for loop that we have at line number 21, we are using the range. So basically, what it is going to do, it's going to go through the slice. Remember, proverbs is just a slice. Okay, so slice of is strings. So basically, we will it is going to uh, parse us these string, and it will be saved into this variable called p. Okay, and it is a colon equals, so that means short declaration. So in this case, p will have this strings in there, and then we have this underscore right here. So that means we we are not interested in the index where the strings are located in the slice. We don't care about that. Okay, we just want to get each string. So once we get the string, what we are doing is to since it's a string, so we want to save it as a byte. So we are basically typecasting this each string, because initially, remember, the proverbs is a string, so that's how this p is going to be, and we typecast it. So now that it's going to be written as a bytes into a file. Okay, and we are using a file handler because we got the file handler when we use the create function from OS package. We are using the file handler to call this write function, and it will start writing. And again, we check if during the write, if anything bad happened. So if anything bad happened, then it is going to come. So it is going to be not nil if anything bad happened. So it is going to come in inside the body of this if statement, and again, after printing the error, it will exit abnormally, because we are passing one. If everything went okay, then it is going to come to line number 27, and in at line number 27, what we are doing is we're saying if, so this if statement is within this for loop. So if n is not equals to the length, that means the length of the string or the length of the slice. In this case, n is n is right here. Okay, so this write is going to be returning some numeric value. Okay, so if n is not equal to length, then fail to write. So basically, in that case, also you want to be able to exit, so terminate the program. Okay, so if it was able to write the data, then it will come to this print line, and that was a success on writing the string. So that's how this will be able to write a slice of string to a file. Okay, so now let's look at read file into a slice. So in the next um, uh, next slide we will do that. So read file into a slice. So how do you read files to a slice? You use the type file io. Okay, I mean io.file can be used to read as a reader to stream the content of a file from the local file system. So basically what we are trying to do is to read a local file which is saved locally on your hard drive. Okay, so that's what this example 5-12 is going to tell us. So in that case, what we have done is imported these three packages now: FMT, OS, and IO. Okay, all these three packages we have imported, and from within the body of main entry point function, we are calling the and using the OS package to call this open function and give the file name. So it will open the file. If the file was opened successfully, then it will skip this piece of code. It starts at line number 10 and it will come to line number 14, and it will not close the file. It will say defer the file, okay, until line number 24. And then at line number 16, what we are doing is to creating a slice of bytes. Okay, slice of byte. And in this case, what we have the length and capacity will be uh, 4. Okay, so they both will be 4. So basically that's how the length of the slice and the length of the I mean the capacity of the slice will be 4. And then remember when we discuss about the slices, if when you're using a make function, it usually it's supposed to take a third parameter also, but if you skip the third parameter, then that is actually a capacity. So capacity will be the same as the slice, in this case 4. So that's why capacity and the length will be same for the slice. And then we have the this basically this will create the slice, and P will have that slice. Now in this case, what we are doing is we are reading, because we are reading from a file, right? The file that we opened it. This is a file handler. So we're using the file handler to make a call to read. Now we are reading from the file to this slice. Remember, this slice is empty at this point when we created this P. P is, has an empty slice. So, so if you really want to see this right here, this is a descriptor, okay, that is, pointing to underlying array. Okay, but in this case, this underlying array is going to be empty. Okay, but it will have 4 4 things in there, because this is 4 and this is 4. Okay, they both will be 4 because we said it. That's how we want to create. So this is the underlying array, and when we give this and start reading it, and once it starts reading, if the file is bigger, then what will happen? If it doesn't fit in there, then it is going to within this read function, they probably have a append. So append will be called, okay, and append will basically will create a new underlying array, to accommodate all the file. Okay, because just reading it from the file, we don't know the size of the file. So underlying array would be keep changing, depending upon until it reaches the end of the file. Okay, once it reaches the end of the file, then that's it. That's how big the underlying array could be. Okay, so we initially created the underlying array capacity 4. Okay, that is the maximum. But once we use the read function has a capability of making the change of the size of this underlying array, because it read function within itself, in a standard library, it uses append, and we already discussed in the last class meeting how the append works. Okay, so append will increase the underlying array size, and that's how the data will be saved from the file into the slice. And then right here, if we check if error equals to io dot end of file, EOF is the end of file. So if it is end of the file, then we want to break out from this for loop. Okay, once it is done, then what it is going to do, it will go from 0. Okay, the slice will starting from 0 to the number of this number of that whatever the number the n has, it will go to that many uh, bytes and print it, the whole string. Okay, so that's what. Now also notice right here that we created the underlying array, which one? This one, which will be of type bytes. Okay, that will be the type bytes. So that means it will save all the bytes in there. But when we are printing right here, so slice will be of type bytes, right? This is the slice. So when we are printing right here, this is actually bytes. So we are converting that bytes to a string, so we can read it. If I don't put this string right here, so basically I'm typecasting it. So if I don't put that, then all I will see is the bytes, to be printed, and I would not be able to recognize the data that was read from this file. Okay, so that is the reason that we are basically doing the typecasting. So now let's go and see the other example, which relates to OS package for standard IO. So let's see right here. Use OS package for standard IO. So basically, OS package, provides a lot of different, functions and other packages and so forth. So what in this example, what we want to see how to use the standard IO. We could use the standard errors or standard in. So, but we are going to use a standard out. Okay, which is right here. To do the output. Standard output basically means your display monitor. Okay, that's a standard output. Standard in is basically your keyboard. So the things are coming from your keyboard, and standard error means some errors that have occurred on the on the output, which you may want to see, you may not want to see. So you can basically dump those errors into a file if you want to. So you can do all of these in different ways. Okay, so that's but OS package provide this for us. We don't have to do any extra coding for it. We just need to be able to use it. So basically, that are of type. So these have a type, okay, and they are of this os dot file type, okay. So print string directly to the standard out using the std out, which is in the OS package. So that's what in this example that we will see, example 5-13. And in the 5-13, very first thing we do is to import these two packages, FMT and OS, and then in the entry point routine main, the body, but we create the slice of a string, same way as we did it in the previous example. Okay, so this slice will be created, and then the slice name is proverbs. Okay, and then at line number 15 we have a for range used to go through the proverbs, and that is going to basically read each line and display it onto the standard out. Okay, so that's what it is going to do right here. Okay, so it is just keep displaying it. If it anything happen when it is displaying it, then then it is going to go in this logic, which starts at line number 17. If it checks if error not equals to nil, then it is going to come inside this. And we already talked about os.exit one, and then it at line number so if everything went okay, then it will come to line number 21, and it checks if n is not equals to length of p, then there is a problem, then you just simply exit out. Okay, so that's all really this will do. Otherwise, if everything is going, it is just keep writing it onto the your display terminal. Okay, so that's what the standard out will do. You keep writing the data to the standard terminal. So let's look at the other example. In this example, we use IO package to read a file. Okay, so let's see how that is done. So the IO copy lets you read all bytes from this reader, okay, which is the interface, and write to an IO writer, which is another interface. Okay, so that's what IO copy will let us do that. So reads from a file and prints to a standard out using this IO copy function as shown in below. So in example number 5-14, what we have is these three packages imported: FMT, OS, and IO. Okay, these are the three packages that are imported. At line number 8, we are going to be inside the uh, main entry point function, and within the body of that function, very first thing we do is to open up this file, proverbs.txt, okay, by using a package os.open, and that will either return an error if something went wrong, or it will return a file handler. Okay, so if nothing was wrong, then it will skip these lines, which starts at line number 20, at line number 10, and of course it is within the body of this if it is using the os.exit, so then it will exit out. The code will not go through. And then at line number 14, I am using a defer keyword, so the file, I want to be able to close it right before this code stops. Okay, and basically at line number 16, I am using a IO copy. So IO copy is going to read from the file and directly write to the os dot standard out. Okay, so it is just reading and writing it to the to the to the your monitor, okay, by using io.copy function. So that's basically this code is doing. And let's see the next example, which is using IO package to write a string to a file. Okay, in this case, we want to be able to write a string to a file. So, this example 5-15, we have imported three packages: FMT, OS, and IO. Okay, and within the main entry point function body, we first thing we do is to call the create function to create this file. So the file will be created. Okay, so that is going to be a text file. By default, it will just create a text file. And then, if anything went wrong during the creation, it will come to this logic right here at line number 10. And it will print out the error, and then it will exit out the program. If everything went fine, then it will come to line number 14, but it would not close the file because we have a defer. Okay, it will defer the closing of the file right before the function or the program ends. And then at line number 15, what we are using the io write string. So io write string is in the package io package. Okay, and we are giving this string, and we are telling which the file name to write it on. Okay, so that's what it is going to do. And if we have any error, which we are checking right here, okay, so it is going to do this only if there are no errors. So this is error not equals to nil, then it is going to write this string. Otherwise it won't write. Otherwise it will just send out this message and exit out. Okay, so that's what this piece of code is going to do. And then let's look at this. Use ioUtil to package, to have to be able to use things from the IO package itself. So package ioUtil is nothing but a sub package. So it's a package inside the package. So offers several convenient functions for IO. Okay, so there are lots of different functions in ioUtil package that can be used. So use function read file to load the contents of a file into a byte. So basically, we want to be able to read and a file and dump it into a slice of bytes. Okay, so that's what we're going to do it in example 5-16. So 5-16 starts with the package main. So we can compile this piece of code, and we import these three packages. In this case, we have a FMT OS, and ioUtil is a sub package. So that's how you import the sub packages. You have to give the the parent package name, and then slice the sub package. Okay, that's how you import the sub packages. And then at line number 8, we start the entry point main function, and the body starts. And then in there, very first thing we are doing is opening up the file. So this read file function is in ioUtil, which does all the things for us. We don't need to do much. It will open the file, and it will read the file both at the same time. So if I would use OS dot open, I'll have to first open it myself, and then I have to call the read function separately. In this case, if I use the ioUtil, it does it automatically for me. On quite a few things. It does a lot of other checking and everything. So this function can be easily used to read the text files. So basically, if the function was succeeded, then this error will be not nil. It will have something. So then it will come into this logic, which starts at line number 10, and print out the error and exit out. Okay. If it was succeeded, then the bytes variable will have some data in there. Okay. And basically it will be a strings. So or actually it will be a bytes, because this read file returns the bytes. So this will just write the bytes. So to see it as a string, you will have to typecast this to a string. Okay. And that's basically it. It will read the data from the file by using the ioUtil function, which has the read file function in there. Okay, which in that case, read file does both, opens the file and also reads the file. And then notice that I do not do the closing. I do not have the defer. So this one also has a defer. So it will basically defer the file. Also, it will close it. So it does multiple things for us. Okay, and in here, the next thing we will go over is to read the file line by line. Okay, so to do that, we are using the bufio package, okay, to read a file line by line. So the bufio package is a package used for buffered IO. Okay, so buffered IO package basically is a technique used to temporarily accumulate the results for IO operations before transmitting it forward. So what it does, in your memory, in the RAM, while the data is read, it is only put into the buffer, whatever the size of the buffer would be, and then it will be sent all together. Okay, uh, to write. So that's how the buffer works, and that's why it is called the buffered IO. So the technique basically can um, the technique can increase the speed of a program by reducing the number of system calls, which are typically slow operations. So in normal conditions, when you have open the file and start reading, then what happens is you may go through a lot of read and writes. So you have to do a lot of system calls. System calls usually requires that it uses the CPU cycles. Every system call that you make a call, it uses a CPU cycle. And as you know, that using too many CPU cycle, it will cause it is more time consuming, and also not good if you are on a small device, the battery operated device, because it will chew up your battery, because if your CPU is working hard, it is using the power, and it will basically take the battery power to run. So that's why you avoid system calls. Of course, you have to use a system call in your code, many different places, but not unnecessarily. So in this case, by using the bufio package, it will create a buffer in the memory, so you don't have to have too many system calls to read and write, or the read operations from the file. Okay, so using this new scanner function, which is in the bufio, okay, will split the text into tokens. So that's the one benefit. So that's how the these small piece chunks are saved into a memory, and when they are enough, then they are sent to basically either read or write. So in this example, 5-17, we have a package. We import the package bufio, and then fmt package and os package. Okay, so these three packages are imported, and in the main entry point function body, what we are doing very first thing is opening up the file ourselves. Okay, because this bufio doesn't allow the automatic opening of the file, like in the previous example that we saw. And the file name is emp.dat. Okay, and basically once you have that, then we are basically skipping the checking of the error. So that's what the underscore right here. I'm not considering that I will have any issues opening up the file. So that's why I don't have a err right here. Okay, and it will have the file handler. Okay, so that's what this open function is going to return, some file handler. And then I'm using a defer. So defer means that this file is not going to be closed until this function is ending. Okay, and then at line number 14, we are creating a scanner. Okay, how do you create a scanner? So basically, a scanner allows us to read a file, okay, the lines. So in this case, we are using the bufio package to create a new scanner, and we are giving the file handler. So that's how the new scanner will go through the file and read the data from that file. And then we are looping through. So in this case, I'm using this for loop and then saying scanner name, okay, scanner file scanner, and then using the scan function from it. So it is going to go through the whole file and read it. So but the whole thing to understand is that behind the scene, when it is reading the file, it is not reading the file all together. It is reading the file into chunks. So that's what this scan will do. It will read the file into chunk and then display it. That's what this will do. It will just print in the print line. We are printing. So this is the file. This is the actual file that was fed right here, emp.dat. Okay, so that's how the this buff io package works. If you want to make sure that your data is very big, but you don't want to consume too many read or use too many read and writes, so the cpu will have to be used because of the system calls. So in that case, you should use the bufio package. So the small chunks are put into the ram, and then once they become a certain size, then they are basically dumped to wherever you ask it to dump, either on the screen, or if you're reading it, or you are dumping it into some file. Okay, so that's the whole idea behind using the bufio. So you save the your extra system calls. So that basically concludes our this chapter 5, and we will start chapter 6 soon. Okay.